Hi, in this video this series of videos we're going to be working through a GCSE paper. Please do stop the video, have a go at each of the questions, then compare your solutions. Each of the videos is going to be about 20-30 minutes or so. It should give you about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment. I'll come back to you and I'll look forward to seeing you inside the video.
Okay, in this particular video we're going to be looking at the Edexcel Foundation Paper 2 from June 2017. So please do stop the video, have a go at each of the questions and then compare your answers. So I'm going to make this video last about 20 minutes to half an hour or so, and we'll work through fairly systematically. Okay, so we've got question number 1. We've got 5p minus 3p plus p. Well, that's going to give you an answer of 3p. Okay, and then we've got part B is simplify m cubed plus m cubed, or m to the power of 3. Now just be very careful here, it's not a multiplication, it's an addition, so we would actually get an answer of 2m to the power of 3. Okay, and then a final simplification, which is this particular one at the bottom here. So what I would do is I would just underline the bits that matter to me. So I've got 3c and minus 7c. Remember that minus is part of it. So 3c minus 7c is going to give us minus 4c. And then if I look at the d's, I've got 5d plus d, and that's going to be plus 6d, and then I've got a 10 over here. Okay, now you could leave it at that if you wanted to. I'm just going to make it a little bit tidier by putting the 6d first. Now I've got 6d minus 4c plus 10, and that would get you the full 2 marks. You would get 2 marks anyway had you written this particular solution. Okay, so let's move on then to question number 2. So it says write that number correct to one significant figure. So what we do is we look at the first significant figure, and my question is, does that change to a 6 or does it stay as a 5? Well, it's going to change to a 6 because the number afterwards is more than 5. Okay, so if it's more than 5, it's going to change the number in front of it. However, that 5 is in the tens column, so I've got to keep it there. So the answer to this particular question is 60. If you're not sure about any of these things, please do leave me a message. I've got lots of playlists and resources available to you, and I'll send you through some links. Okay, let's have a look then at question number 3. This is a fairly typical bar chart. A teacher asks the students in year 6 what type of transport they use to get to school, and we've got a dual bar chart. So the grey there is boys, and then the hatch there is girls. Okay, so it says part A is what is the most popular type of transport used by the boys? Well, that's going to be walking. Okay, now what I'm going to do at this particular point is just add up, or at least just make a note of the numbers of students in each of these bars. It just makes my life a little bit easier to do that, because it means then that when I come to the final question, I'll be able to add them up fairly easily. However, I've got to remember that part B is 7 girls walk to school, which is this one here, and show this information on the dual bar chart. So if we go to 7 on the dual bar chart, that's going to go something like that, and because it's girls, it's going to have a hatch in it, and I'm going to write the 7 just above there. Okay, so then if I look at question number, or part C, it says more of the students get to school by car than by bus. How many more? Okay, so this is where adding up the different bars is just a little bit easier for us. If we go back to cars and buses, we've got 14 students that went by car and 10 students that went by buses, and all I'm doing is I'm adding the numbers at the top of the bars there. So 14 and 10, so the difference is going to be, in this particular case, 14 take away 10, which is going to equal 4 students. Okay, and then finally it says the number of students in year 5 is the same as the number of students in year 6. What's the total number of students in both years? Okay, so all we've got to do really is go and add up all of these numbers. Okay, and when I add up all of these numbers, what I actually get is going to be 48. Now don't forget, this is the bar chart for got year 6 students. So therefore, right at the very bottom here, I've got year 6 students equals 48. And if it's the same in year 5, then year 5 students is also going to equal 48. Add those two together, I'm going to get 96. So the number of students in years 5 and 6 are going to be 96 students altogether. Okay, hopefully that's okay for you. Let's move on then to a very common kind of fraction type question where really we're comparing order of size. So we're going to start with the smallest fraction. In order to do that, I need to make sure that the denominators for each of these are going to be the same. Now what I'm going to do is I'm going to choose 30 because I can multiply that by 6 and therefore I multiply the top by 6 and that becomes 12. I can multiply this by 15 and then I multiply the top by 15. Now if I do that, I'm going to get 15 at the top, okay, and then I'm going to multiply this by 2 and therefore I multiply that by 2 and that's going to be 14. So it allows me now to look at each of these fractions and say, well actually the smallest fraction is going to be this one, which is 11 over 30. The next biggest one is going to be the equivalent, which is 12 over 30. And then I've got 14 over 30, so that's number 3. And then number 4, I've got finally 15 over 30. So if I write those out in order, what I'm basically going to get is going to be 10 over 30. And that's going to be then 2 over 5. And then 7 over 15, and then finally 1/2. Okay, now you could write them as the equivalent number over 30. So in other words, write out the numbers that I've got here, so these ones. Okay. However, I suggest you don't because you would lose a mark. What you need to do is make sure that you go back to the original question. Okay, hopefully that's all right for you. Let's move on then. Okay, so here we are on question number 5 and it says write down one thing that's wrong with the tally chart. Well actually it just takes a little bit of looking at, but basically this number at the top should be 13. Okay, so the frequency is incorrect. Okay, and if I just put frequency incorrect for Monday, and it should be 13. Okay, let's have a look then at the second part of the question. David drew this pictogram to show the information for Tuesday and Wednesday. So in other words, if we look at the top here, we've got 18 and we've got 8. So in other words, what we're saying is the value of Tuesdays should be 18 and the value of Wednesdays should be 8. Well, what have we got? Well, actually, if each of these little symbols represents 3 CDs, then we've got 3, 6, 9, 12, 15. So actually we need an additional, so Tuesday, an additional symbol, okay, to be 18 CDs. Okay, and then the other thing that we you might want to spot is that actually for Wednesday this is equivalent to 1.5 CDs. Okay, because it's half of that symbol and half of 3 is 1.5. So Wednesday can't have, and we've got 7.5 CDs. Okay, and that'd be perfectly fine for that question. You would get, it's a 1 mark question, so it's a little bit of work for 1 mark there. Okay, let's move on then to question number 6. There's 495 coins in a bottle and a third of the coins are £1 coins. Okay, now this is a calculator paper, so if you have a calculator available, you would work out a third of 495, and that's going to be 165 coins, and therefore the monetary value of the £1 coins is going to be £165. Then it says 124 of the coins are 50p coins. Okay, so basically if we've got 124 coins, I'm going to divide that by 2 because 2 50p's is going to equal £1. Okay, so therefore we can just work out how many pounds we've got by just dividing 2 into 124, and we get £62. So therefore in 50p coins we've got £62. Okay, all right, hopefully that's okay for you. So let's have a look then at the rest of the coins are 20p coins. So the first thing is we need to find out how many we've actually got. So if we look at the information, we've got 20p coins, and we've got in total 495 coins, and then we know that 165 of them are pound coins and 124 of them are 50p coins. So that's going to give us 206 coins. Now 206 coins which are all going to be 20p's. Okay, so we've got to work out the pound value of that. So I would say that the easiest thing would be to do 206 divided by 5, because 5 20p's equals £1. Okay, so therefore if I do that calculation, I should be a little bit careful here, because you are ending up with 5 into 206 is 41 remainder 2. So in other words, what we're saying is that we've got £41, but then we've got 2 20p coins, so it's going to be £41 and 40p. So this is 2 times 20p, that little bit that's left over there. So now I've got my components to be able to add up the value of the 495 coins. I've got 165 plus 62 plus 41.40, and if I add all of that up, I'm going to get £268 and 40p, and that would be the answer to this particular question. Okay, let's move on then to question number 8. So question number 8, the probability that a new fridge has a fault is that. What is the probability that the new fridge does not have a fault? So it's fairly straightforward with a calculator. So it does not have a fault would be equal to 1, which is perfect. So 1 is no fault at all. Take away 0.015, and that's going to be 0.985, and that would be the answer to that particular question. Okay, let's have a look then at question number 8. I see these questions quite a lot. From the numbers on the list, write down a square number. Okay, well, a square number is a number where you multiply the same number by itself and you get equal to, in this particular case, 25. So 25 is a square number, as is something like 36, which is 6 times 6, or 81, which is 9 times 9. Then it says, from the list of numbers, write down a number that is a multiple of both 4 and 6. Well, 4 times 6 is 24, which is actually on the list, so we can actually say 24 for that one. And then it finally says, write down all the prime numbers on the list. Okay, now a prime number is a number that's only divisible by itself and 1. And the key issue with this one is it says all, so there's more than 1. Okay, so if we go back to the list, it's going to be 23 and 29, because you can't divide those numbers by anything other than themselves and 1. Okay, let's move on then to question number 9. So if we have a look at that one. This is one that's not too bad really. What you need to know with this is that the degrees around a point are actually equal to 360 degrees. So if I sort of have a big circle there, that circle is 360 degrees. I know this is going to be 90 degrees, and I also know the others are 3x and 2x. So therefore I can write myself a little formula. I can basically write 3x plus 2x plus 90 equals 360 degrees, and then really it's a case of solving for x. So if I make that 5x plus 90 equals 360, I take 90 from both sides, I'm going to get 5x equals 270, and then I divide by 5, I'm going to get x equals 54, and that's the answer to that particular question. Okay, hopefully that's all right for you. Let's move on then to the next question, which is going to be question number 10. Okay, so Suha's going to buy 150 envelopes, and she's got two choices. She can either go to Letters to Send or Stationery World. She wants to buy the envelopes as cheaply as possible. Which shop should Suha use to buy the 150 envelopes from? Okay, so let's have a look at the two options. So if we look at Letters to Send, well, it's going to be fairly straightforward, because basically she needs to buy 6 packs because she wants 150. She's got a pack of 25, so therefore that's going to be 6 packs Okay, and each pack is going to cost £3.49. So in your calculator you can do 6 times 3.49, and that means that her cost is going to be £20.94 at letters to send. Okay, hopefully that's all right for you. Let's have a look then at stationery world. Okay, right, now this one's slightly different. In that we've got to buy 15 packs again because we want 150 envelopes, and there's 10 envelopes in a pack, so we want 15 packs. But however, because there's a 2-for-1 deal, it means we're actually only going to pay for 10. Okay, so for every 2 packs we buy, we get 1 pack free, so therefore we just pay for 10 packs and we're going to get 15 of them altogether, which is what we want. So therefore what we're looking to do is to say, well, it's £2.10 per pack. We multiply that by 10 and that's going to be £21. Okay, so by 6p, letters to send is slightly cheaper. Okay, is cheaper, and that would be the answer to that question. Now, just as a point here, generally speaking, with these sorts of questions, you're going to get, they're very close. You wouldn't have a difference of tens of pounds or anything like that. Usually it's only a few pennies in it. Okay, let's move on then to this one, which is a standard comparison chart. It's a single line chart. We're comparing centimeters to inches. Okay, so the first one is it says change 74 centimeters to inches. Now that's just going to be slightly difficult to show on the video, but I'll do my best, because effectively what we need to do is draw a line at 74. Now what I'm going to do is draw this on the screen, but if you download the actual completed exam paper from the website from 3 Minute Maths, it's a little bit neater than the way I'm going to do it. Okay, so hopefully it'll be alright for you. 74 is actually going to be here. Okay, this is 70, and then each of the small blocks is going to be 2. So 74 is going to be here. Okay, and I'm just going to basically take that all the way down here. Okay, now if I'm going to change 74 centimeters to inches, it's going to be the equivalent to 29 inches. Okay, which is this point here. Okay, hopefully that's all right. Now, it's a little bit trickier because I'm going to move on to part B, which is on the next question. It says Daniel's height is 6 foot 3 inches and 1 foot equals 12. What's Daniel's height in centimetres? So what we need to do is work out firstly his height in inches. So it's going to be 6 multiplied by 12, because that's 12 inches in a foot. And then I'm going to add 3 onto the end of that, and that's going to give me 75 inches. Okay, so we need to find his equivalent height from the graph by using the comparison that we've got. However, the problem is that we don't actually go to 75 inches, we only go to 50 inches. So okay, well, probably the easiest way is to use that 50 inches and then also to recognise that 75 can be divided into 50 inches and 25 inches. So 50 inches, if I go all the way to the top here, okay, I'm going to come all the way over, it's actually going to be it's not fantastic on the screen, but it's actually going to be 128, I think I'll go with, maybe 126 or 127, but there's always a bit of variation on these. So I'm going to say that 50 inches is going to equal 128 centimeters. Okay, and there is variation, so don't be concerned if your reading is slightly different to mine. Okay, now I do need 75 altogether, so I'm going to divide this in 2. I could go back and take it from the graph if I wanted to. However, I'm going to say, well, that's going to be a half of 128, and that's going to be 64 centimeters. So when I add those two, I'm going to get 192 centimeters, which is the answer to this particular question. Okay, hopefully that's okay for you. Let's move on then to question number 12, which is just as straightforward. Put it in your calculator, but do be careful with this. Always use the fraction key and also use the brackets as it's got there. It's probably not a good idea always to do this separately. It's better if you kind of get to know the fraction key on your calculator. And what you should get is 0.07330359081. Okay, or at least certainly on my calculator that's what I got. You probably will get much the same with that, maybe to more decimal places or fewer decimal places. Okay, so we're going to move on to question number 13, which is a rotation, and it asks us to rotate shape A 90 degrees clockwise about center 0. Now, under normal circumstances, what you would do is use a piece of tracing paper, and if you put your tracing paper onto the center and then draw on the tracing paper the shape, you can then rotate it around. However, I'm going to do it slightly differently, because what I'm going to do is I'm going to create a 90 degrees from that point, and what it means then is I know that point has gone through 90 degrees from there to this point, so therefore I'm going to put that there. And actually I can see, or I can do the same with all the other points, because if I look at this point here, then it's actually going to be 4 along and 4 down. So therefore I'm going to go 4 along and 4 down again, okay, and it's going to come out at this particular point here. So this is B and this is B prime. Okay, so I've got some kind of key points there, and then really it is a case of looking at this and doing the same. You probably will find it easier to work with tracing paper, but I'm just going to draw it on the screen as I would see it, and I'm going to get that point and that point. Okay, and that means then that I can draw this in as this kind of shape like that. If you're not sure about what I've done there, please do let me know. I do have a worksheet and videos on reflection which are done with tracing paper, so you'll be able to see how that works. Okay, let's move on then to part B, I think it is. Describe fully the single transformation that maps B onto triangle C. Okay, well this one's fairly straightforward. It's basically a reflection in the y-axis, and that's where effectively x equals 0. And if you could imagine, if you sort of put a mirror here, then you're going to reflect B onto C, and that would be the answer to that particular question. Okay, so we're going to carry on, and we're just going to do a few more questions. So we'll have a look at question number 14 and 15. So let's move on then to 14. So factorise 5 minus 10m. Well, the biggest number I can take out of 5 and 10 is going to be 5. I can't take anything out of the m, so I'm going to write that as 5 1 minus 2m, and that would be the answer to that question. Okay, so the next one is the word fully. You've got to be careful about that. So I can take out 2, because 2 is common to both, but also I can take out A, and I can also take out B, okay, because B is common to both, and then I end up with A plus 3B inside the brackets, and that would be the answer to question number 14b. Okay, let's move on to some standard form. So it says write that as an ordinary number. So what it's telling me is the decimal point has moved one place in the negative direction, so it becomes 0.47. okay, hopefully that's all right. And then finally part B, it says work out the value of this. Now if you put this directly into the calculator, you're going to get 228 0 0 0 0, that's 4 plus another 3 at the end, so that's going to be your answer on the calculator. Now that would give you perhaps 1 mark, it depends on the marking scheme, because they're asking you to change it to the standard form. So what we're saying is the decimal point has moved 1 2 3 4 5 6 7 8 9 places. So in answer to the question, it'd be 2.9 0.28 multiplied by 10 to the power of 9. So just be really clear with where you put your decimal places on these types of questions. Okay, so I'm going to move on to the final question on this particular video, which I'm going to leave this at the very end because it's not going to be a fantastic drawing. I'm going to do the best I can without having a sheet of paper and a pair of compasses to work with. Okay, so the first thing is we've got 3 points A, B and C, and the information here is that 1 centimetre represents 100 metres. Point T is 250 metres from point A, so therefore it's going to be 2.5 centimetres. Okay, so if I had a pair of compasses, what I would do is I would be able to draw a circle around there, and that circle is representative of 250 metres, but in the actual drawing it's going to be 2.5 centimetres. Okay, and then it says right at the bottom here, point T is equidistant from points B and point C. Okay, so in other words, what we need to do is we need to get the centre of line BC. Now the way we do that is we take a compass and we draw an arc, and then we take the other side and we draw another arc. Okay, and therefore we've now got what's called the perpendicular bisector. Okay, so that's this line that goes through here. Okay, and that is the equidistant between B and C. Okay, so point T, which is what we're trying to get, has to be 250 metres from point A, so I can do that, and it has to be equidistant from point B and point C, and it says on the map show one of the possible positions. Well, I'm going to show that as being exactly at this point, which would be point T. Point T therefore is 250 metres away from point A and is equidistant between B and C. Okay, so apologies for my dreadful drawing there, but hopefully it's been useful to you. Please do let me know in the comments, and I'll look forward to seeing you inside the next video.